Good evening, everybody. Today I got my hands on this vacuum tube and I thought it would be interesting to see if we could make a one triode amplifier. So the tube that I've got is actually from a television set, and it's what's called a vertical deflection tube, but it's a dual triode in that it's got a larger power triode and a smaller signal triode, and the power triode can handle a maximum of 7 watts and a plate current of 35 milliamps, which should be enough to make a small audio amplifier. Our end goal is basically this circuit here, where our grid current controls a larger current flowing through from the anode to the cathode through this output transformer. An interesting thing about valves, unlike transistors, is that they're normally conductive and they conduct a lot more current than the valve can actually handle. So for that reason, our grid needs to be biased a lot more negative than the cathode. So for that reason, we have this cathode resistor here, which has the effect of raising the voltage of the cathode, so we can pull the grid below the cathode voltage. So one of the first things that we need to do is try to figure out what kind of value resistor we want here, and how we do that is, firstly, we want our 35 milliamps flowing through there. And what grid voltage do we need to get our 35 milliamps, you might ask? Well, that is where our data sheet comes in handy. And what this shows us is we've got a plate voltage along here, our current along here, and these are different grid voltages. So we're kind of aiming to get somewhere around the middle where the plate characteristics are relatively linear, and our 35 milliamp spot is about there, and we might opt for, say, 150 volts on our plate, which means that we're aiming somewhere around there, which is a minus 20 volts on our grid. So now we know the voltage, and we know that we're going to have somewhere about 30 milliamps. So that means what we want to see here is 0, 20, and 35 milliamps. So 0, 20 volts, and 35 milliamps. And so what we can do is get out our calculator and go 20 times 0.035 milliamps is that right? No, 20 divided by 0.035 milliamps, and we get a value of 570 ohms. So we've got a 680 here, which might be a little bit too large, but we'll give it a shot. And we want to place this one from the cathode to our ground, which in our case goes from there to there. There we go. I'm just going to, so the next thing that we want to do is have one end of our transformer go to the anode, which we can do with this. And we'll also need a capacitor on our grid. And this resistor here is just to bias the grid down to our 0 volts so that our grid is at 20 volts below the cathode. This can be quite large because the grid doesn't take any current, it's high impedance. So we've got a 1 megohm that can go from the grid to the ground, and we're going to need another little jumper to go on our power supply. This is a little power supply that I got from eBay, which boosts 12 volts up to 110, 200, 220 or 280 volts, and it's handy because we can run the heater using the same power supply that we're running our plate. Need a little screwdriver. I'm going to run my multimeter in series with this transformer and the plate so we can have a look at how much current is flowing through this circuit to see if we get our 35 milliamps. So we hook our anode up to the multimeter, and we put the other end of our multimeter on our little transformer. I think, oh yeah, and we also need to hook up our heater. So we'll turn the heater on, and we expect the heater to draw 0.45 amps at 13 volts. It draws a lot more at the start until it slowly warms up. And there we go. Now we want to turn this around to milliamps, and we'll turn on our anode supply. Oh, we were current limited for a bit there. And we've got 15 milliamp flowing through there, which might be because our cathode bias resistor is a little bit lit big, or perhaps because we don't have quite enough voltage across the tube. If you remember, we're looking for 250 volts, so let's just have a look from our anode to cathode voltage. That's on the anode, that's on the cathode, and we've only got 88 volts, which means that we are losing a big bunch across this transformer potentially. No, only losing 0.8 across the transformer. Is our supply not? Our supply is only giving 100 volts, but we need more than that, and we're losing about 10 volts across the cathode. Alright, let's turn that off for a moment, and what we'll do is we will turn up our boost converter to get a bit more voltage. The next notch over is 200 volts. Right, turn our heater back on. So expect closer to 30 millivolts this time. We'll turn our anode supply back on. Hey, that's looking pretty good, 25 milliamp, and we are now seeing (148 volts across the plate to cathode, and we are seeing minus 17 volts on the across the cathode bias resistor. So that's actually relatively close to our diagram, where we've got minus 20, 150 volts, and we'd expect something around 25 or 30 milliamp of bias current. So the next thing that we're going to do is we are going to put a signal from my signal generator onto the grid, and I imagine that we'll hear some kind of noise. So we need a ground connection for my signal generator, and we'll put the other end of the signal generator on the capacitor. And hey, how about that? We're hearing a terrible noise. I won't expose you to that too much more, and so that's all there is to it. I need 3 components and we've made a single triode amplifier.